Good day, everyone. So, once again, we were given 2 weeks to cover our new topic, which is none other than biconditional, inverse, converse, and contrapositive statements. Let us begin. For this particular lesson, we have the following objectives. Number one, to determine the inverse, converse, and contrapositive of an if-then statement. Also, we are going to illustrate the equivalences of A, the statement and its contrapositive, and B, the converse and inverse of a statement. So what do we know so far? We've learned about conditional statements. So, it's commonly known as the if-then statements. But we've also learned that that's not always the case. There are cases wherein the conditional statement doesn't follow the if-then format. So conditional statements is like saying if this happens, then that will happen. The important thing here is to identify which is the hypothesis and which is the conclusion. So this is where the keywords are very helpful. So after the word if, we often find our hypothesis, and after the word then, we find our conclusion. So in symbols, we write it this way, which is read as if P, then Q, or P implies Q. Here's an actual example. If x is an odd number, then x plus 1 is an even number. Okay, let's put that up here so that we could focus on that example. So, the hypothesis, yeah, the keyword is if, right? So, the hypothesis is x is an odd number. And the conclusion is x plus 1 is an even number. Okay, that's the first step. The next step is you should be able to identify or determine what is the truth value of that statement. So, mahalaga na malaman natin whether a conditional statement is true or false. Okay? So, it is said that a conditional statement is false if the hypothesis is true, but the conclusion is false. Okay, let's take an example. If a student is in 8th grade, then he or she is 14 years old. Okay? The hypothesis here is a student is in 8th grade. Okay, that part is true. Okay? So it's just like stating a fact. So what if we have a student who is an 8th grader? Okay, then he or she is 14 years old. That is our conclusion. That conclusion is false. Why? Because we could think of a counterexample or an instance wherein that conclusion becomes false. Okay, we could have an 8th grader who is 12 years old. We can have an 8th grader who is 13 years old. We can have an 8th grader who is 15, 16, 17, or 18. Okay? So, it is not always the case wherein an 8th grader is 14 years old. Therefore, the conclusion is false. Okay? Since we have a true hypothesis but a false conclusion, this conditional statement is false. Okay? Okay, how about this one? If x is an odd number, then x plus 1 is an even number. That is our given conditional statement. What if we reverse it? Not reverse, we interchange the position of the hypothesis and the conclusion. So when we say interchange their position, the conclusion becomes the hypothesis and the hypothesis will become the conclusion. So, if x plus 1 is an even number, then x is an odd number. Okay, so in the original statement, P implies Q. But on the second statement, Q implies P. Okay, the first statement is our conditional statement. What we call the second statement is converse statement. Okay, please take note of that term. Okay, converse statement. Okay, now let us check the truth value. On the first statement, or our conditional statement, our hypothesis is true and our conclusion is also true. For example, x is 5. 5 is an odd number, right? So 5 plus 1 is 6. 6 is an even number. So this statement is true. How about our converse statement? Is this also true? X plus 1 is an even number. This part is true. It's just like saying that this is our given. X plus 1 is an even number. Okay? X is an odd number, then X is an odd number. Our conclusion is also true. Okay, let's prove it. If we have X plus 1 as an even number, so let's say number 6. So the only possible value of X to make this statement true is 5. Because 5 plus 1 is equal to 6. And 5 is an odd number. Okay? Let's take another example. If x plus 1 is an even number, let us say 20, the only possible value of x is 19 because 19 plus 1 is equal to 20. Okay? So, again, 19 is an odd number, which makes the conclusion true. Okay, so what do we have? We've learned that our conditional statement is true. And also, the converse statement is also true. Okay, so since both of them are true, we could rewrite another statement. We could write it this way. X is an odd number if and only if x plus 1 is an even number. Okay? So this is a new kind of statement. We call it the biconditional statement. A biconditional statement can only be formed if and only if both the conditional statement and its converse statement are true. Okay? Let's have a recap. Take a look at this example. If the fruit is an orange, then it contains vitamin C. Okay? This is our conditional statement. So again, if we're going to get its converse, okay, we will make its conclusion as the new hypothesis, and the original hypothesis will now become its new conclusion. So if the fruit contains vitamin C, then it is an orange. This is our converse statement. Okay, let us check. In the first statement, the fruit is an orange is true. It contains vitamin C is also true, because indeed, an orange contains vitamin C. But in our converse statement, the fruit contains vitamin C. The entire conditional statement is therefore true. Okay, the hypothesis the fruit contains vitamin C is true. But the conclusion that it is an orange is false. Okay, because there are other fruits that contain vitamin C. We have a kiwi fruit, we have grapes, apple, pineapple, and a lot of other fruits. Okay? Therefore, if the hypothesis is true and the conclusion is false, therefore the converse statement is false. If this is the case, we cannot write a biconditional statement. Okay? Again, a biconditional statement can be formed if both the conditional and converse statements are true. Okay, let us introduce a few more other statements. But before that, what if the given is the biconditional statement? So we started off with the biconditional statement. An angle is right if and only if it measures 90 degrees. So the key word that it is a biconditional statement is, key words are if and only if. Okay? So an angle is right is our hypothesis, and it measures 90 degrees is our conclusion. Okay? So, remember, our biconditional statement follows the conditional statement. So let's write the conditional statement first. Okay, we change the if and only if phrase by the if then, the original if then form. So if an angle is right, then it measures 90 degrees. This is our conditional statement. And then from the conditional statement, we could write our converse statement. So if an angle measures 90 degrees, then it is a right angle. Okay, that is our converse statement. Okay? So, like I've said a while ago, let us introduce a few more statements. Okay, here, if an angle is right, then it measures 90 degrees. This is our conditional statement. Now, instead of changing the position of the conclusion and the hypothesis, this time we will negate the conclusion and the hypothesis. When we say negate, we will write the opposite of each part. So, if an angle is right, the opposite is it is not right, right? Okay, so if the conditional statement is P implies Q, this time around, we will write it this way. If an angle is not right, then it does not measure 90 degrees. Okay, this is called the inverse statement. Okay, the inverse of the conditional statement. So, in symbol, we write it as the negation of P implies the negation of Q. Okay, so from the conditional statement, we could write the converse statement. Okay, so if an angle measures 90 degrees, then it is a right angle. In symbol, Q implies P. Okay, now let us negate the converse statement. So let's write the opposite of the conclusion and the hypothesis. If an angle does not measure 90 degrees, then it is not a right angle. So this is what we call a contrapositive statement. So we have the negation of Q implies the negation of P. Okay. So again, thank you very much for joining us and listening to the lesson. Please stay tuned for the continuation of this lesson. We will proceed to proving in the next week. Okay. Again, thank you and keep safe, everyone. Bye bye.